Okay, let's dive right into this. If you're a Delphi developer, I guarantee you've been here before. You've got some heavy lifting to do in your code. Maybe you're processing a huge data set, loading a big file, you name it. You click the button to kick it off and then nothing. Your beautiful, responsive UI just stops. It's frozen solid. Clicks do nothing, the screen won't even repaint, and your poor user is sitting there convinced the app has just crashed. It is a classic, frustrating problem. And for years, there's been this tempting one-line fix that a lot of us have reached for. But as we're about to see, that so-called fix, especially when you're developing for Android, is really nothing more than a trap.
So here's the game plan for this explainer. We're going on a bit of a journey. First, we'll really nail down that frustrating UI freeze problem, what it is and why it happens. Then we'll look at the deceptive quick fix that seems so magical at first, but is actually hiding some deep, serious dangers. We're going to expose those dangers and talk about a particularly nasty bug producer called reentrancy. And then we get to the climax, the Android breaking point. This is where that quick fix goes from just being risky to being absolutely fatal for your app. And of course, we'll wrap up by looking at the modern, the professional, and frankly, the correct way to solve this problem for good, using proper threading. All right, let's set the stage. We're talking about the core issue, that one problem that I think every single developer, regardless of language, has had to battle with at some point, the dreaded UI freeze.
I want you to really picture this. Your user clicks a button to start some big, important calculation. They see a progress bar, but it's not moving. They try to click the cancel button, but it doesn't respond. They can't even drag the window around on the screen. From the user's perspective, your application is dead. And that's when the panic sets in for us developers, right? What do you do now? How do you fix this? So here's the technical reason why this happens, and it's absolutely crucial to understand. Your app's main thread, the UI thread, is basically a very busy multitasker with a critical flaw. It can only do one thing at a time. It has two main jobs. Job 1, run your Delphi code, like that big calculation we mentioned. Job 2, listen for user input, clicks, keyboard presses, and handle all the screen repainting. So when it gets stuck in a long loop doing job 1, it completely neglects job 2. It can't process new events, it can't repaint the screen, everything just grinds to a halt.
And that brings us to the famous, or maybe infamous, tempting solution. One source I read described it perfectly as the lazy, terrible solution. And honestly, they're not wrong. It's the powerful, dangerous lure of a single line of code, application.ProcessMessages.
So what is this thing?
Well, if you look at Embarcadero's own documentation, it says it's a procedure designed to interrupt your code's execution so the application can process whatever messages are waiting in its queue. Back in the day, in the old Windows VCL world, this seemed like a miracle. You could just sprinkle this line inside a long loop, and magically, your UI would seem to catch its breath. It could process paint messages, respond to clicks. It seemed to fix the problem.
Now this right here, this is where the deception really ticks in. The contrast between what you think it's doing and what's actually happening under the hood is massive. It seems like you're just politely telling your app, hey, just take a quick pause and check for any UI updates. But what you are actually doing is far, far more chaotic. You're basically telling your app to stop dead in its tracks right in the middle of your button click handler and start processing everything and anything that's waiting in the message queue. This creates an incredibly dangerous situation, a loop within a loop.
And that loop within a loop is where the real nightmare begins. You think you're just letting paint messages through, but you're actually opening the floodgates for any and all events to fire, which leads to a terrifying condition called reentrancy. You know, you don't have to take my word for it. This is a direct quote from a very experienced developer on Stack Overflow, and it just perfectly captures the expert consensus on this. The advice is completely unambiguous. Never, ever use it. Using process messages is quite literally inviting trouble into your codebase. So what is this trouble we're inviting? It's reentrancy. Let me paint a picture for you. Imagine your code is chugging along inside that long loop that was started by clicking button A. It hits your application process messages call. The user, who is now thrilled that the app isn't frozen, gets impatient and clicks button A again. Or maybe they click button B, which happens to modify the same data. Well, because of process messages, the event handler for that new click starts running immediately, before the first one has even finished. Your code is now executing in a jumbled, interleaved, unpredictable order. You've got different parts of your code stomping all over the same variables, corrupting data, and creating the kind of bugs that are an absolute nightmare to track down. For a long, long time on the desktop, using process messages was just considered bad practice. It was risky, it was messy, but you could sometimes get away with it. But now, with modern FMX on Android, this bad practice turns into a fatal error. This is the breaking point where everything changes.
So, what happened? Why did this go from being just risky to being fatal? The critical change happened with RAD Studio 10.2 Tokyo, specifically Release 2. See, before this version, FMX on Android actually ran its own UI thread, which was separate from the main Android operating system's UI thread. This separation caused its own set of synchronization problems, but it meant that process messages could sometimes, limp along. But starting with 10.2 R2, Embarcadero made a huge architectural change. They unified them. The FMX UI thread is now the Android OS thread. This was a fantastic move that fixed a ton of other bugs, but it was a death sentence for the application.processMessages hack. And here is the magic number you need to remember: 5 seconds. On the Android operating system, if you block the main unified UI thread for about 5 seconds, the OS itself steps in. It assumes your app is broken, that it's locked up, and it presents the user with that dialog box we all hate to see: application not responding. And it gives them a nice big button to kill your app. So, let's put all the pieces together. When you call application.processMessages inside some kind of while loop on a modern Android build, you are literally trapping the one and only UI thread. You're holding it hostage. It can't process the very messages it might need to exit your loop, like maybe a state change that your while condition is checking. The thread is completely, utterly blocked. After 5 seconds, Android's internal watchdog timer goes off, it declares your app unresponsive, and it's game over. It's not a random bug, it's a guaranteed freeze every single time. Okay, so enough of the doom and gloom. If process messages is the trap, then what's the way out? The answer is to stop fighting the operating system and start working with it. We need to embrace the architecture that modern OSs are designed for, and that means multi-threading. This isn't just a workaround, it's the professional, stable, and correct way to build a responsive application today. The logic here is actually incredibly simple and powerful. It breaks down into 3 key steps. First, any work that's going to take more than a few milliseconds, seriously, the threshold is that low, must be offloaded from the main UI thread and moved onto a background thread. Step 2, this frees up the UI thread to do its most important job, which is staying responsive to the user and the operating system. And finally, step 3, when your background work is done and it needs to update the UI, say to change a label's text or update a progress bar, it must do so safely. You have to marshal that update back to the main thread using specific functions like synchronize or queue. And that's the golden rule. Never, ever touch a UI control directly from a background thread. And just look at the difference in practice. This slide says it all. On top, we see the old, ugly, problematic code, a blocking while loop that traps the main thread, desperately calling process messages just to stay alive. Now compare that to the modern asynchronous solution on the bottom. We create a task that runs on a background thread. When that task is finished, it safely sends the UI update, in this case changing a label's text, back to the main thread. The UI thread itself was never blocked, not for a second. It's clean, it's safe, and it just works on every single platform. The best part is Delphi gives you this amazing toolkit right out of the box. For those really complex, long-running background processes, the classic T-thread is your reliable workhorse. For shorter, more fire-and-forget type operations, T-Task from the Parallel Programming Library is absolutely fantastic because it uses a managed pool of threads for you. And then when you need to talk back to the UI, you get to choose. You can use Synchronize, which will actually pause your background thread until the UI update is complete, or you can use Queue, which just posts the update message and lets your background thread continue its work immediately. You have all the tools you need. So this really brings us to the final, and I think most important question. The need to even consider calling application.processMessages is really a symptom. It's a sign of an older, blocking application design. The future of robust, cross-platform development, especially on mobile platforms like Android, is asynchronous. By taking the time to move your long operations to background threads, you're not just fixing a bug, you are fundamentally modernizing your application's architecture. You're building apps that are stable, that are responsive, and that are ready for the future. So the question you have to ask yourself is, which path is your code going to follow?